Okay.
We are proving triangles similar today. So first theorem says if you have two pairs of congruent corresponding angles in two triangles, then that means the triangles are going to be similar. This only works for triangles. This does not work for any other shape, okay? So triangles only. Triangle. Not work for quadrilaterals or anything else. The reason this works is because, I don't know if you remember this, but back when we did triangles, there was the third angles theorem. So it said if two angles and two angles are congruent, then the third angles are also going to be congruent. And essentially for triangles, if all the angles are congruent, then that means the triangles are going to be similar. Again, only applies to triangles, does not apply to other shapes. Okay? All right, so what we're going to do is for the following triangles, we're just going to see if they're similar. In order to determine if they're similar, we're going to compare the corresponding angles and make sure that they're congruent. So first set, we have 45 and 45. So we have one pair of congruent angles. Now, do we know any other measures?
Yeah, 90 degrees.
What do we know now?
Oh, no.
Actually false. We know that there's a vertical angle
Yeah.
theorem.
So we do know that these two
Sorry.
angles are going to be congruent. So we know angle RSW is congruent to angle VSB by the vertical angle theorem. We don't know what it is, but we know that they're congruent. Now, is that good enough?
Now I have to find W and B.
Do we?
No, actually triangles are correct.
Two angles is good enough. So we have one pair of corresponding congruent angles. We have two pairs of corresponding congruent angles. So we can say triangle RSW is similar to triangle VSB by the angle similarity postulate theorem. Postulate. They're like mini proofs.
No, please no. No proofs at all.
So all we need is two. Now, if we can't get two, then they're not similar. So let's look here. We have one pair here. So we know angle L is congruent to angle R. What we don't know is J is supposed to correspond with P, and we don't actually know P. Q is supposed to correspond with K, and we don't actually know K. So we need to figure out what one of them is. What do you want to find? Do you want to find P or do you want to find K?
I want to find K.
K is easier, right? So we know that the angles in this triangle have to sum to what?
180.
180. So if we have 100 of them, what's K?
80.
43.
80. Now, is angle K congruent
False.
to angle Q?
No.
No. So these are not similar. So triangle JLK is not similar to triangle PRQ. Side piece. Okay, why is he saying that? I guess we could go a step farther and find this one, but not gonna make any difference. Okay, bye.
So basically what I did is I added 90 plus 39 equals 180. I did the math. I got 129 minus 180. And that would be 51. Therefore, you can conclude that they are similar. So use bigger words.
His name is Eric.
So you did math, you found that this was 51,
Mm-hmm.
which is good because we know that right angles are congruent, and now we know that this angle, which corresponds to that angle, is congruent to that angle. So we can say that they're similar because they have two angles congruent. Good. Now there are more theorems. One is called the side angle side similarity theorem. and one is called the side-side-side similarity theorem. And again, these only apply to triangles. These do not apply to other shapes. The first one says, if you have a pair of corresponding sides that are proportional and the included angle is congruent, then the triangles will be similar. So for example, maybe this side is 5, this one's 10, this is 6, and this is 12. So they're proportional in the same way. And then maybe this angle is like 30 degrees and this angle is 30 degrees. So that would mean that the triangles are similar by side, angle, side. Because you have the same ratio here. See how it's like, these are like, this one's double this one and this one's double this one. So same proportion. And then the two included angles are going to be congruent. So that's your side, angle, side similarity. They can also be similar by having 3 sides proportional. So for example, maybe this is 5, this is 10, this is 6, this is 12, and this is 7, and this is 14. So each set of corresponding sides is proportional in the same way. Like they all have the same scale factor, or that all the extended proportion is equal to the same ratio. Okay, so all of this would have to, each one individually would have to be equal to the same number, like 1/2, or 1/3, or 5, or 12, whatever. But they'd have to all be the same. So if they're all the same, then we know that the triangles themselves are similar. Again, only applies to triangles. All right, example 2, we're trying to determine if the triangles are similar. So what we're going to do is we're going to take each corresponding side and we'll check the ratio. So what side corresponds with SU?
WX.
Hmm?
WX.
WX, are we sure about that order?
Indeed.
Yes.
No.
XW.
It's actually going to be XW.
I can do that.
All right, so this SU is 10, and then XW is 15. Does this simplify?
5 over, no, 2 over 3.
2 over 3. Okay, so that's 1. Now we shall check this one, the shortest side. Oops, whatever. All right, so if I call the one on the left ST, what do I call this one?
XV.
All right, if ST is 6 and XV
It's
is
2 over
9,
3 again.
it's 2 over 3 again. Is this enough?
No.
No, I need another side, or I would have needed the included angle. But we don't have the included angle, so we gotta check the third side. Yeah. Yeah. All right, so if I call this UT, what do I compare it to? So if I do UT, it's gonna be
VW.
WV.
Oh.
That will be wrong if just like, the letter will be
Yeah. All right, what does that simplify to?
2 over 3.
Okay, so it says, are the triangles similar? If so, write a similarity statement for the triangles. So are they similar?
Yeah.
Yes?
Yeet.
Our similarity statement is going to be, we'll say triangle SUT is similar to triangle X W V, yeah, that's the last one, by the side similarity theorem. So just be careful that you're not accidentally putting congruent. Remember, these are similar. Questions?
No.
Let's look at the next example. Here we have a triangle inside of a triangle. They look similar, but I don't know if they are. The length of this side corresponds with the length of this entire side. How long is the whole thing?
10.
10.
Yes.
So KL and KM are related in the ratio 8 to 10. Do you see how that works?
Mm-hmm.
that means that if we simplify this, we should get,
4 over
4/5.
let's check these ones. So KP
Oh,
There.
corresponds with KN. How long is KN?
5.
15. So that means this ratio is equal to 12 over 15.
3 again, so it's 4 over 5.
So is that enough?
No.
No.
No. We don't know the lengths here. So I can't use side, side,
So
side.
therefore it is not.
Yeah, angle. K.
Do we have an angle?
No.
Yeah.
The included angle is angle K.
Side angle side.
Angle K is congruent to angle K by what property?
Reflexive.
Start.
If you look, K is the included angle for both of those triangles, and it's shared because they're overlapping. So obviously K is going to be congruent to itself. So that's enough. I have side angle side similarity now. So I can say triangle LKP is similar to MKN by the side angle side similarity theorem. So basically, you want to either show 2 angles, side, or 3 sides. If you can't show those, then our AE is equal to 6 over 12, because we're talking about the whole thing, which simplifies to 1/2. And then AL over AC is 8 over 16, which also simplifies to 1/2. And the included angle is angle A. So angle A is congruent to angle A. You could either say by the reflexive property, or you could say because right angles are congruent. So we know that triangle EAC is similar to triangle WAL by side angle side similarity. If your letters are in a different order, that's fine. You just want to make sure that the appropriate corresponding letters are like set up that way. So you want to make sure E and W are corresponding, A and A are corresponding, and C and L are corresponding. That's pretty much it. Alright, we're gonna look at this little proof right here. It doesn't mean we're doing proofs, we're just gonna
Now.
look at a couple.
No for me, dog. It's a no. It's a no for me. Actually, I'm
Alright, so
very terrible.
what's the first thing we put in every proof?
The given.
Yes.
Actually, that's wrong. You put vertical angle theorem.
I thought it was the give on.
Vertical angle theorem seems like a better
True.
statement. Or CTPC.
CPEC 921.
Do you remember what an isosceles triangle is?
Yes, both sides, 2 sides are congruent.
And
Angle are congruent.
Angles, yeah.
that's what goes here. Base angles are congruent by the definition of an isosceles triangle. What that means in the picture, if this is an isosceles triangle, these angles are congruent, and if this is an isosceles triangle, these angles are congruent.
Sounds great.
That's what it says here. Angle F is congruent to angle H, angle J is congruent to angle L. And this is the isosceles triangle theorem. Actually, I think here they want us to say that the triangles are isosceles. I think that's what they want. So triangle FGH and triangle JKL are isosceles by the definition. They're isosceles because they have 2 congruent sides. and because they're isosceles, we know that their base angles are congruent. Alright,
Brilliant.
so there's like two paths here. One, we're gonna start with this. So F is congruent to H because of the isosceles triangles. This part right here says that F is congruent to J. So F is congruent to J. Why is that?
Given.
That is given. It's given in the picture with the little swooshy things, but it's also given right here. We're gonna build like a bridge here. So if you look, it says F is congruent to H, F is congruent to J, and therefore
H is congruent to J.
H is congruent to J. So why is that?
Transitive property.
Yeah.
Property.
So it's technically the transitive property of congruence, but if you just put transitive property, that's fine. There's another little bridge here. So J is congruent to L by the isosceles triangle theorem. And then
Okay.
It's the same.
hang on, I'm trying to figure out which bridge I'm going. I want H, L. Okay, so if J is congruent to L and J is congruent to H, then we know that H is congruent to L by the same transitive property, just in a different order. Now, if we know that we have two pairs of corresponding congruent angles, then we can say that the two triangles are similar by what?
By AA similar.
Yes. So we can say that they're similar by the angle similarity postulate, because we have two pairs of corresponding congruent angles. So essentially we just needed to kind of get to the point where we either had two congruent angles or an included angle in between two proportional sides, or all sides are proportional, which we didn't have any of that.
You try.
I don't think there's a U try.
Yeah, there
Is there? Ah, there is a U try. Alright, U try.
Max.
Might have to dig deep into your repertoire of theorems. Okay, so the first one's the given. It says C is congruent to M. Does anyone know why?
AIAT.
Yes, that is correct.
AIAD.
What do these little thingies
Alternate
mean?
interior line.
What do these things mean?
Parallel.
Parallel. So remember, if lines are parallel, we're looking at either alternate interior angles, corresponding angles, same side interior angles, alternate exterior angles. Those are like all of our things from parallel lines. So it's the fact that they're alternate, because if you look, they're on other opposite sides of this transversal, and these are the parallel lines. So they're congruent by the alternate interior angle theorem. Now it also says that A is congruent to P. Why are those congruent?
Same.
Alternate interior.
Yeah, same thing. Now, you could also have used these if you wanted to instead.
Vertical angle.
And those are congruent by the vertical angle theorem. So you could have used that instead of either this one or this one. Either or, but you would still need one of the alternate interior angles. And then the final thing is the prove. Why are the triangles similar?
Angle.
Angle, side angle?
Angle,
Oh.
Similar.
similarity. Because we have angle, or angle, or angle. We don't have any sides, so it can't be one of the other ones. Questions? Right, so the next ones are more like solving using similar triangle concepts. So you can use indirect measurement to find lengths that are more difficult to find directly. So stuff that's like really close or really far away. If you look at this picture, this is like a little dude. He's standing and he's looking at a mirror, I believe. Yeah, there's a mirror here. The mirror is reflecting the top of this cliff, and he wants to know how high the cliff is. Well, he can easily calculate how far he is from the mirror, and he can easily calculate how far he is from the base of the cliff, but he can't calculate how high it is because he doesn't have a tape measure that long, but he does know how tall he is. So he knows a thing or two. He knows how tall he is, he knows how far he is from the mirror, and he knows how far the mirror is from the base of the cliff, but he doesn't know how big the cliff is. Too big.
Dude,
So what we're gonna do,
That just says like one day I'm gonna go out to this cliff. I'm just gonna stick a mirror on the ground.
I'm gonna solve this equation.
I'm gonna solve this equation. Like no one's gonna stop me. You must have to be like really rich and old.
we're gonna solve a proportion relating these things. Now your proportion could look like a number of things. My proportion's gonna look like this. I'm gonna take the height of the dude and I'm gonna put it over his distance from the mirror, and I'm gonna set that equal to the distance the mirror is to the cliff, and that is gonna be equal to the height of the cliff, or before you set up a proportion, you just wanna make sure that all the units are the same. Are all the units the same?
Indeed.
Yeah, they're all in feet, so just make sure of that before you continue. Alright, now we're just gonna solve the proportion super easy. So we have 5.5 times 34
I believe that is 136.
Alright, let me.
equal to 6x.
130.
187.
Okay.
Wait, 187?
Mm-hmm.
Oof, I was a little bit
70.
off.
Oh.
So you said?
No, I just
Can I
added
calculate
the
that just to
points.
make sure?
No, it's right.
Yeah, 187.
Okay, and then we divide by 6.
Oh, okay, cool.
Will be
1 point something.
And a sixth.
Sorry, 1.166.
Yeah. So if you put 6, so 6 goes into 18 3 times. And you bring down the 7.
Then what
6 goes into 7 once. And then there's 1 left over, so that's 31 and 1/6. So that means that the cliff is 31 and 1/6 feet tall, or high, or whatever.
Now how old are the rocks?
Oh my god, Eric.
Alright. See how that works? Now, keep in mind there's other proportions you could do. You could do 5.5 over x equals 6 over 34. You could switch these two and do 5.5 over x equals 6 over 34. There's like a number of proportions that you can do. So whichever one makes sense to you that isn't wrong is fine. It's easy to do it in feet because it's 5 feet 6 inches, but if it's anything but that, you probably just want to put everything in inches. So we're going to do 5.5 over 4 equals x over 10. That's just one way. Multiply this way and you get 55. Multiply this way and you get 4x. And then you can divide by 4. So it's not going to go in evenly, but we need it to make sense in context of the question. So we need to know how many times 4 goes into 55. So 4 goes into 5 once, 1 left over. 4 goes into 15 3 times with 2 left over.
Oh.
Okay, so that's 13 and a half. So 13.5 feet. Good job.
So I can
3 left over.
13.75.
Okay, I was gonna say, like,
3
what?
left over.
13.75.
Yeah, yeah, just kidding. 3 left over.
It's a 165 inch.
I'm great.
Next ones are just like regular triangles, so not indirect measurement, but just the same concept. We can set up some proportions to solve these. We just wanna make sure that the proportion is relating the correct corresponding sides. So for example, 2x corresponds with what over here?
9.
9. Okay. And then what corresponds with, say, 8?
X.
X. So this is, again, one way to do the proportion. So we're gonna cross multiply. 2x times x is 2x squared. 9 times 8 is 72. To solve, you would want to first divide by 2. So 72 divided by 2 is x squared equals 36. And then we're going to square root both sides. So if you remember, I told you to
6.
put plus
Plus
or
or
minus
minus.
6.
X is 6.
However, with this question, since it's relating to triangles, can this be negative 6?
No.
No. So we're just going to say x equals 6. Because when we're talking about triangles, we can't have negative segments.
Yeah, you can't.
Okay. Try that you try.
Only tedious problem.
So just make sure you're at least
I
multiplying the right
absolutely
things
did
together.
something completely wrong.
So I took the base or the longer leg of the first triangle and I put it over the longer leg of the second triangle. Then I took the hypotenuse of the first triangle and put it over the hypotenuse of the second triangle. That's my proportion. So I'm relating long leg, hypotenuse, hypotenuse. So again, if you rearranged it in a different way, as long as after you cross multiply, you're multiplying the two x things together and the two constants together, then you should be okay. Now, when you do multiply these together, you have to FOIL. So 2x times x is 2x squared. 2x times 6 is 12x. Negative 4x times x is negative 4x. Negative 4 times 6 is negative 24. And then on the other side, I have 24 times 39. 936. That's a big number. When you have a quadratic, which is an x squared term in your equation, then you need to get everything on one side of the equation, and you're probably going to either factor or use the quadratic formula. So I'm going to combine these two together, which is 8. And then we're going to subtract 936 and combine it with the 24. So you should get negative 1060. Yeah? Yes? No? Me?
Yeah, maybe
No, 960. Just kidding. Not that big. Okay. Okay, so we have a quadratic equation. If you can take that quadratic equation and simplify it, then you want to do that. Can this be simplified? Yes. We can divide each one of these by 2. So we're dividing both sides of the equation by 2. So divide by 2, divide by 2, divide by 2, divide by 2. And you should get x squared plus 4x minus 48 with 0 equals 0. So once you reduce it, you can either use the quadratic formula or factor. So I'm just going to rewrite this over here. Okay, so let's go over factoring. In order for us to be able to factor this, you're looking for two numbers that will multiply to negative 480 and add to 4. Okay, so things that multiply to 480, 1 and 480. If we want it to be negative, we're looking at either negative 1 and 480 or positive 1 and negative 480. Do those add to 4?
No.
No. So we need stuff that's closer together. So think, what other things multiply to 480? And if you're not sure, you can just go through like a very long list.
Definitely the fifth one.
I would say it's bigger. I mean, what's
60 and 8 and it's not 4.
hmm?
No, it just say 60 and 4.
16 and
No, it's 60 and 8. But it's not adding to the 4.
you have to add the 4. Mm. 30 and 6.
There's no word.
16.
There's no word.
Does like let me threes go there. How about like does like
Oh, 24 and 20.
24 and 20. Whoops. Yeah?
Yeah. 24
Oh,
and
that
20.
one works. Nice.
Yeah.
In order for this to work, you would need a negative 20 and a positive 24. Okay, if you can't find it, then you can just plug it in the quadratic formula with A as 1, B as 4, and C as negative 480. Like if you can't think of the factors, if you can, it's usually easier to factor. So positive 24 and negative 20 will multiply to negative 480 and add to positive 4. After you factor, you take both of your factors and you set them equal to 0, and then you solve the two like mini equations. So if we solve this, we would just subtract 24. If we solve this, we would add 20. So we get two solutions. Now, in some situations, you wouldn't keep both solutions, you would get rid of one, like this last one. We got rid of negative 6 because it doesn't work. If you look at negative 24, if we plug this back in, what happens?
Yeah.
It's negative.
It's negative. So we don't want to keep that one, we just want to keep 20. Okay, so 20 is our answer. Now again, you could also use the quadratic formula, which would look like this. But you'd probably need a calculator. I think either way, you probably want a calculator for this question.
Yeah.
Unless you have it.
Usually when I give you questions like this, I'll still make you do this work, but I'll make the numbers a little bit smaller so they're easier to find since you don't have a calculator.